Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to write the second order linear differential equation as a system of differential equations. So this is going to bring our second order work into line with our systems work. So let's think about this. Our general second order linear differential equation is of the form y double prime plus b times y prime plus c times y equals 0. And this is our homogeneous or our null solution. And here's what we're going to do. Oh, remember, this is solved by the characteristic equation or the characteristic polynomial, characteristic polynomial we said it was s squared plus b times s plus c equals 0. All right, here we go. Let's write this as a differential equation. Well, first off, let's do a little bit of thinking. Remember, we have the vector y prime equals a times y. So that would be our null equation. We have a null second order equation, so we're going to write this as a null system of equations. Well, here's where it gets a little bit interesting. Notice that if I take the derivative of y, I need to get y prime. And I need it so that I pick up a y double prime, a y prime, and a y. So here's what we do. We say this. We say let y equal, we're going to work with our notation for a little bit, but we'll start with this one. Let y equal y, that seems obvious, and y prime. Well, what does this tell us? This tells us that the vector y prime is the vector of y prime, and then y prime prime. Well, that's y double prime. Oh, okay. Well, there's my y prime. Well, what do I know? I know that this has to give me some matrix times the vector y. So let's write this. So here's some matrix. Well, actually, times, we're going to have some matrix here times the vector y. So that's y prime. Well, how we get this is a little bit creative. Notice this. Notice the second row, I think, is where it becomes most apparent. The second row says that y double prime equals something. Well, let's go back to our equation, our original equation. That's y double prime plus by prime plus cy equals 0. And let's solve that for y double prime. So this is going to become equal to a minus cy minus a by prime. Well, let's do it this way. Before we write the matrix, it may not be so obvious. Let's write what we have. So we have y prime is equal to y prime and y double prime. Well, this is equal to, well, we just figured out what y double prime is. We said this is minus c times y minus b times y prime. And, well, y prime, it can't be, we don't want to solve for y prime because then we're going to get y double prime back into the equation. And so let's just say that y prime is, in fact, just y prime. Now, I'm writing it this way by design because look at what it is. The y's and the y and y prime, those are the weights, if you will. So if you think of it this way, this is really the matrix of my first column vector is 0 minus c. My second column vector is 1 minus b. And then my vector of scalars are the functions y and y prime. And there it is. We just did it. And there's our y prime, y double prime on the left-hand side. And then further, what we do is to make this fit notation that you're more comfortable with, is we often say let y1 equal y and y2 equal y prime. And then this can be written as y1 y2 prime equals 0 minus c, 1 minus b times the vector of y and y prime. Now you might wonder, like, is that really going to work? Well, let's think about this. If I was to solve this, we've practiced this, well, what we would do is we would take the determinant of, a minus lambda I. We'd set that equal to 0. Well, let's see if this is going to work. In other words, are we going to get back to, will this get us back to, I'm going to grab my highlighter. Will this get us back to our characteristic polynomial? Let's check. Well, remember the determinant of a minus lambda I is lambda squared minus the trace. Well, the trace in this case is 0 minus b times lambda plus the determinant. Well, the determinant is 0 times negative b minus negative c times 1. Well, this is lambda squared plus b lambda plus c equals 0. And look at that. It's the exact same equation, but now we have a lambda instead of the 0. And that is how we can then take a second-order differential equation and solve it as a system of first-order differential equations. I hope that helps, and thanks for watching.